Hello and welcome to this video on exponent examples. Now in the previous videos of exponents we've done exponent laws as well as a few examples, and here are a few more. So what we're going to do, we're going to apply those laws and solve these examples. Feel free to pause, try these by yourselves, and then use it to mark and see if you've got the right answer. Okay, so onto this question. First things first is whatever's not a prime base, we'd like to break it into its prime base. So this is equal to 2 to the power 4 n minus 1. That's already a prime number. And this is 2 to the power of 2 minus n. That's already a prime number, so it's fine. Once again, 3 to the power of n is also a prime number, so that's fine. And 6 is not a prime number, but we can write it as 2 times 3 to the power of 1 minus n. And once again, 8 is not a prime number, and we can write it as 2 to the power of 3. Once we've got it all in prime numbers, what we're then going to do is first let's distribute that out. So I'm going to write everything as already is. Okay, and we distribute to each one by multiplying. So this will become 2 to the power of 1 minus n, and 3 to the power of 1 minus n, and times 2 to the power of 3. Okay, so what's left for us to do is to put it over a like base. So if the base is the same, and then because we're multiplying, we're going to add. So this is going to be 2, 4n minus 1 plus that exponent, 2 minus n, plus that exponent because it's also over 2, so 1 minus n plus that. We're going to do the same thing for 3. So here we have 3 to the power of n plus 1 minus n. So when we're multiplying, we add the exponents. So now what we're going to do is we're going to add those exponents. So we have 4n minus n, which is 2n. And we have minus 1 plus 2 plus 1 plus 3. So that is 5. And then we have n minus n for the 3, which is 0 and just 1. So this simplifies just to 2n plus 5 times 3. Let us do another one. Okay, so here we have a fourth root and we have the sum. So first things first, we first break into prime numbers. Also, I like to write our roots as a power of a quarter. In the previous videos, we did say why this is true. So 3 is a prime number, so we just have it there. That's the power of a. And 9 we can write as 3 squared, and that's the power of a plus 1. All over 27 is 3 to the power of 3, and that's the power of a plus 2. So once again, we're going to distribute. That's 3a stays there. So this we multiply by 2. So it's 3, 2a plus 2. Don't forget to multiply both terms with the 2, because lots of people just multiply the first one. And we're going to do the same thing in the denominator. So this is 3a plus 6, all to the power of a quarter. Now we're going to group them over the same bases by using our exponent laws. So the law is when we're multiplying, we add, so we can add those, plus 2a plus 2. And when we're dividing, we're subtracting. So this is actually minus, and watch, I put the whole thing in brackets because we have to change the sign of both of those. And that's all to the power of a quarter. Okay, so let's just simplify that. That's 3a plus 2a plus 2, and that minus will change both of the signs in the bracket, and that's all to the power of a quarter. See, so that minus, we distribute it. So now let's group our like terms. A plus 2a minus 3a is 0, so the a's cancel out. And then we have 2 minus 6, which is minus 4 to the power of a quarter. So what we do is when we're raising to a power, we multiply 4 times a quarter. So this is 3 minus 4 times a quarter, which is simply minus 1, which we can then write as a positive exponent by taking it to the denominator. Next one, same set of rules. First break into prime bases and then go on and apply the exponent laws. So the prime bases of 10 is 2 times 5. and that's n plus 3. 5 is already a prime number, so we just leave it over. 50 as a prime number is 2 times 5 squared to the power of n minus 2. Okay, once again, we're going to distribute. Now remember, those have exponents of 1. So it's going to be 1 times that. So it's going to be n plus 3. And then again, 5 to the power of n plus 3 times 5 to the power of n minus 1 all over. And again, we'll distribute that to each one. So first case, we're multiplying the 1 with n minus 2. And in the second time for the 5, we're multiplying 2. And once again, don't forget to multiply with both terms. So it's 2n minus 4. Okay, so let's group our on like terms using our exponent law. So when we're multiplying, we're adding, and when we're dividing, we're subtracting. So this here is n plus 3 minus, now that's an n minus 2. We're minusing because it's in the denominator. And then we'll do the same thing for the 5s. So that n plus 3, then we multiply that, so we add the exponent. And then we're dividing, so we're subtracting. So it's minus 2n minus 4. Okay, so let us write that's 2n plus 3 minus n plus 2. Watch these little details like it changes the sign. So this is 5n plus 3 plus n minus 1. Distribute to both, so it's minus 2n plus 4. And once again, we then group n minus n, those cancel out, and we have 3 plus 2, which is 5. And then n plus n is 2n minus n, they cancel out, and then we have 3 plus 4 minus 1, which is 6. So this here, we can just leave it as 2 to the power 5 times 5 to the power of 6. Okay, that was simple enough. Let's try another one. So this one here, exactly the same concept. It's just going to be a bit longer because there is more in the question. So first step, prime bases. 9 is 3 squared to the power of 2k plus 2. 3 to the power of minus k, that's already a prime base. 4 is 2 squared to the power of 3 minus k all over 3, and that's already a prime number, so we can write the exponent. 6 we know is 2 times 3, and that's 3 minus 2k and times 2. Okay, so now we distribute. Again, we multiply the 2 with both terms, so this is 2 4k plus 4 times 3 minus k times 2, 6 minus 2k. So we've distributed that 2 to both terms. And in the denominator, we're going to do the same thing. So this is 3 to the power of 5k. We're going to distribute that exponent to both of them. So it's 2 to the power of 3 minus 2k times 3 to the power of 3 minus 2k times 2. Now we put them over the same bases. So we've got a 3 over there. If we're multiplying, we add. So it's 4k plus 4. And we're multiplying that, so we're adding plus minus k. And then we're going to subtract what's in the denominator. So minus that 5k and minus 3 minus 2k. We do the same thing for 2. So here we have 6 minus 2k. Minus 3 minus 2k minus, now there's no exponent, so it's 1 over there. So we're going to go up there. So this here is 3. I'm going to simplify this. So it's 4k minus 6k, which is minus 2k, plus 4 minus 3 plus 2k. So I've just distributed that again. And then for the 2, we have 2, 6 minus 2k minus 3 plus 2k minus 1. So again, don't forget that distribution step. So this here, we're going to say is 3 minus 2k plus 2k, they cancel. And then we're going to have 4 minus 3, which is 1. And again, we have minus 2k and 2k, they cancel. We have 6 minus 3 minus 1, which is just 2. So this here is just 3 times 4, which we can write as 12. another one. So you see that with enough practice, you can master these concepts quite easily. So the steps are the same. Prime bases. So this here is 3 squared to the power of a plus 1 times 3a plus 2. It is already a prime number over 3 cubed to the power of a plus 2 times 3 squared to the power of a minus 2. Okay, so this here is 2a plus 2 times 3a plus 2, all over 3a plus 6. Notice how I'm distributing to both of the terms. Don't make that mistake where you don't. 2a minus 4. So now we're going to use the rule that if we're multiplying, we're adding. So it's 2a plus 2, and we add that, plus 3a plus 2. And then over here, we're subtracting, so it's minus 3a plus 6. And again, subtracting minus 2a minus 4. Then we distribute. So it's 2a plus 2 plus 3a plus 2 minus 3a minus 6 minus 2a plus 4. So let's group our, we have 2a plus 3a minus 3a plus 2a, so that's 5a minus 5a, so the a's all cancel. And then we have 2 plus 2, which is 4, minus 6, which is minus 2, plus 4, which is minus 2. Is that right? 4 minus 2, 2. Sorry, positive 2, right? I feel like 8 minus 6, yes. So this is 1 over 9. Okay. I lie, it's just 9. You guys should be watching for these things. Okay. The last one, and then we're done with these, practicing these examples. So 2n minus 1 times 3 squared minus 4n times 3 cubed n plus 2 all over, we have to distribute that minus, so it's 3 minus 3n minus 1. Let us go on. 2n minus 1 times 3 minus 8n times 3n plus 6 over 3 minus 3n minus 1. Then we use the multiplication rule. This is 2n minus 1 minus 8n plus 3n minus 6 minus 3n minus 1. So that is 3 to the power of 2n minus 1 minus 8n plus 3n minus 6 plus 3n plus 1. So 2n plus 3n is 8n minus 8n, that was all cancelled. And we have minus 1 plus 1 cancel, so we just have minus 6. So we would like to make this positive, so we move it to the denominator. Okay, so those are the examples that we've done. Please, it's very important that you get the practice you need. Anybody can master these sums and be an A student with enough practice and guidance. Please try these questions by yourself and see that you get the same answer. Watch out for the next videos where we'll do another type of question